Some places on Earth are simply too dangerous for humans. Not because they're underwater, not because they're in space, but because the air itself can become deadly. Inside damaged nuclear reactors, radiation levels can become so intense that sending people inside isn't an option. And honestly, that's where some of the most incredible robots ever built go to work. At first glance, these machines don't look like movie robots. They aren't covered in shiny armor. They don't walk like humans. Most are compact, rugged, and built for one purpose: survive an environment that humans can't. The challenge is enormous. After a nuclear accident, engineers need information. What's damaged? Where are the obstacles? How much radiation is present? Can repairs begin? But answering those questions often means entering places that are simply too dangerous for people. That's where robotic inspection systems become essential. Equipped with cameras, radiation sensors, thermal imaging equipment, and specialized tools, these robots travel through reactor buildings collecting information that engineers desperately need. And the footage is fascinating. Dark hallways, twisted metal, pools of water reflecting flashlight beams. Every movement is slow and deliberate, because one mistake could mean losing the robot forever. Some machines use tracks similar to military vehicles. Others crawl. Some climb stairs. Others squeeze through narrow openings designed for maintenance crews. Every design depends on the mission, because no two nuclear facilities are exactly alike. The engineering challenge goes far beyond movement. Radiation itself is the enemy. High radiation levels can damage cameras, interfere with electronics, corrupt computer systems. Even the robot's own components have to be carefully selected to survive long enough to complete the mission. That's why engineers often build these machines with hardened electronics and redundant systems. Every extra minute inside the reactor can provide information that helps protect human workers later. And honestly, watching the robots explore feels almost like watching a rover on another planet. The environments are silent, empty, almost frozen in time. Yet the robot keeps moving, scanning, recording, sending information back to engineers waiting safely outside. Some of the most famous examples came after the Fukushima nuclear disaster. Robots entered areas where radiation prevented human access, helping teams better understand the damage inside the reactors. Without those machines, many inspections simply wouldn't have been possible. And that's what makes this technology so important. These robots aren't replacing people, they're protecting them. They enter first, they gather information, they reduce uncertainty, and they allow engineers to make smarter decisions before anyone else steps inside. The technology continues improving every year. Better mobility, stronger communications, more durable electronics, artificial intelligence capable of helping navigate complex environments. Each new generation expands the places humans can safely explore through machines. And honestly, that's what makes this story pure TECHRUPT. Because sometimes the greatest engineering achievement isn't building a machine that's faster, or stronger, or bigger. Sometimes it's building one that's willing to go where no human safely can.